Truncus will be very similar to hyperbola, and the simplest truncus will be 1 over x squared, and you have the graph like this. You still have x, y asymptotes as x equals to 0 and y equals to 0 as the asymptotes, and the feature is the domain is R except 0, but the range will be different compared to hyperbola. That will be R plus. Okay, that will be everything above 0. So R plus also can say 0 to infinity. Also can say from 0 to infinity. So that will be very, very similar. So, but one thing you need to understand, this equation is 1a over x minus h whole thing squared plus k. That is a truncus. Okay, that is a truncus. But if you have gx equals to a over x squared minus h plus k, this is not truncus. Okay, if you learn Spanish, you will know what is it, but this is not a truncus. Okay, this is not the truncus. It must be the whole thing squared. Okay, the bottom it should be in the square form, and that is truncus. That's a reciprocal function. The bottom is a reciprocal function. You are not going to do this in methods, so that's not a truncus. Okay, so how we can sketch that? Okay, step number 1, still find asymptotes. So the way to find asymptotes will be exactly the same as how to find asymptotes for hyperbola. The second one is to find, okay, which two parts I have graph. Do I have graph in here, which is a greater than 0? Or do we have graph for here and here, that's a smaller than 0? Okay, which part of the graph, which part I have the graph? Number 3, yep. Not R minus, is below the asymptotes. What is the asymptotes? That is the asymptotes. So all the value below the asymptotes. No, R minus is from negative infinity to 0. That's R minus. But for example, asymptotes is y equals to negative 3. Then it's negative infinity to negative 3, not R minus. Okay. It's not the same. R minus is asymptotes at 0. So that's R minus. Okay, so if there is xy intercept, find it. Okay, sometimes they're not necessary to have xy intercepts. For example, you have graph like this. Okay, there's no xy intercepts. It's above, and x equals to 0 is the asymptote. So in that case, you're not necessary to have intercept. So if there's intercept, go to find intercept. Okay, so let's have a look at the questions here. Okay, so you have fx equals to that. Let's make it larger. Fx equals to that. So same thing, I want to find asymptotes. I cannot have denominator equals to 0. So if the denominator equals to 0, I will have asymptotes. So x equals to minus 2 and y equals to minus 3 will be the asymptotes. Y will be minus 3 and x will be negative 2. Okay, you will have this graph. You have this graph and this graph. And you need to find xy as intercept. So you can see intercept, so you need to find them. So when x equals to 0, y will be 1 over 4 minus 3. So 0 plus 2 is 2. 2 squared is 4. So y equals 2 minus 11 over 4. Okay, so that's the point here. Next one is when y equals to 0, 1 over x plus 2 squared equals to 3. Okay, that should be 3. And then I will have 3x plus 2 squared equals to 1. And x plus 2 squared equals to 1 on 3. Okay, my question is, what x plus 2 equals to? Okay, x plus 2 equals to what? Plus minus root 1 on 3. But I need to rationalize the denominator. I'll have plus minus root 3 on 3. Okay, times root 3 on both top and bottom. You have root 3 over 3. And x will be minus 2 plus minus root 3 on 3. Because you have 2 intercepts, so this one will be minus 2 minus root 3 over 3, comma 0. And this one will be minus 2 plus root 3 over 3, comma 0. Okay, it needs to be symmetrical. Okay, it needs to be symmetrical. So the domain will be R except the x value you cannot take, which is minus 2. And the range will be, okay, the range won't be R except negative 3. So let's see, is above the asymptotes you have graph. So the range will be start from negative 3 and to infinity. Okay, minus 3 to above. Minus 3 above, not including minus 3, because minus 3 is the asymptotes. So I have minus 3 to infinity. Okay. Next one, you have y equals to 2 minus 1 over 2x plus 1 squared. Okay, so you may a little bit worry about the 2. So the 2 can be divided on both top and bottom, so the 2 doesn't really matter. Okay, so what's the, if I write the equation in this way, y will equals to minus 1 over 2x plus 1 squared and plus 2. Okay, the first thing is asymptotes. So the bottom equals to 0, x will equals to negative 1. So y will be 2. So the asymptotes is negative 1 and 2. Okay, we have negative 1. X equals to minus 1. And have y equals to 2. Oh. Okay. And because it's negative 1, so the graph is either go, okay, the graph will be go this way. Okay, for see this part, it can go this way. Okay, can see the graph? It can pass through this way, or it can pass through this way. Okay, pass through here. So I need to work out what is the xy intercepts first. So let's go to find xy intercept. When x equals to 0, y equals to 2 minus 1 over 0 plus 1 is 1, 1 squared is 1, 1 times 2 is 2, so y equals to 3 over 2. Okay. This is here. Okay. And to find x-intercept is when y equals to 0, 1 over 2x plus 1 squared plus it should equals to 2, right? The thing should equals to 2. And then I'll have 4 bracket x plus 1 squared equals to 1. X plus 1 squared should equals to a quarter. Then I will have x plus 1 should equals to plus minus a half. X equals to minus 1 plus minus a half. So x can be minus 3 on 2, or x can be minus a half. Okay, minus 1.5 and minus 0.5. Which is this point and this point and this point. Okay, graph will somehow looks like this. Okay, and this is 0, 3 over 2. That point is negative a half, comma 0. That is negative 3 over 2, comma 0. Okay, so let's talk about what's the domain. The domain will be R except minus 1. Okay, can't take x equals to negative 1. And what is the range? Range will be everything below the asymptotes. So the asymptotes is 2. So that's the highest point you can get. Negative infinity to 2. Okay, negative infinity to 2. Okay. Any questions so far? No? No? Okay, if no questions, let's have a look at the last one. Okay, let's have a look at the last one. In the last one, we have, what we have at the bottom, we have 3 minus 2x whole thing squared. Okay, the whole thing squared. So, let's find asymptotes. Still find asymptotes first. So the asymptotes, okay, the whole thing squared is satisfied as a truncus. Okay, satisfied as a truncus. So what I need for truncus, like I can't have denominator to be 0, so let's make that equals to 0. So 3 will equals to 2x. X is 3 over 2. Okay, x is 3 over 2 and y will equals to 1 because the 1 here is y equals to minus 1 over 3 minus 2x whole thing squared and plus 1. Okay, so whole thing squared and plus 1. Okay, next thing is let's find the x. Let's sketch out the graph first. So we have 3 over 2 and 1. x equals to 3 over 2, and this is y equals to 1. Okay, I'll have graph at the bottom because it's a negative. So still the same problem. The graph can go through this way or it can go through this way. So I need to find the xy intercept first. So let's go to find xy intercept. When x equals to 0, y equals to 1 minus 1 over bracket 3 minus 0, 3 minus 0 equals 2, 3 squared equals to 9. So y equals to 8 over 9. So 0, 8 over 9, which is really close to the asymptotes, which is a point here. So when y equals to 0, 1 needs to be equals to 1 over 3 minus 2x whole thing squared. So 3 minus 2x squared equals to 1. 3 minus 2x equals to plus minus 1. Minus 2x will equals to plus minus 1. Subtract by 3. And x will equals to plus minus 1 plus 3 divided by 2. So x will equals to 2 or x will equals to 1. Okay, 1 or 2. One and 2, which is here and here. So the graph will go through this way. And this way. Try to draw it parallel in the end. And that is 2, 0 and 1, 0. And here is 0, 8 over 9. So we talk about domain. Domains are except 3 over 2. And have a look at the range. Range is everything below 1. So it's negative infinity to 1 round bracket. And everything below 1 is possible to take. So it's negative infinity to 1. Questions? No? Okay, so that's it for truncus.